What's up, nerds? Mr. Kowalczyk here. Thanks for doing good work and being respectful. So today what we're going to be doing is we're going to be doing 1.6 transformation practices. Actually, no, I take that back. It's 1.12 transformation practice. So we're moving forward. You did this last year in Alg 2, so hopefully a lot of this rings some bells and reminds you of transformations of functions. So first off, when we apply transformations, we need to consider sequencing. So sequence is going to be really important. To make this easy to remember, we're going to do H, S, R, V. Thank you for following along with your notes. Horizontal, right? That's sliding side to side. S is stretch. R is going to be reflection. And V is a vertical shift. Okay, they go in this order. H, S, R, V. Horizontal shift comes first. A stretch, whether you stretch the function up or sideways, you reflect it over the Y or the X axis. And then a vertical shift where you take the whole function, you just slide it up or down. Okay, so now that we're going to use this table, this is going to be really helpful. Keep this in your notes for sure. So in this particular case, we're going to fill in some blanks here, and we're going to come back to the way that it appears and what you do to the point in a little bit. So H, as we said, stands for horizontal translation. That's the first thing that we're going to do. Now, notice that the translation is going to be inside of the parentheses. Anything that happens to the X coordinate or the shift is going to be inside the parentheses. And here the vertical, that's going to be a vertical stretch or a horizontal stretch. And I have compression here because it can also squish the function. It can make it smaller or it can stretch it out. So, what we do with that function is like silly putty or Play-Doh. We can stretch it out or shrink it up. And then R, we reflect over the X-axis, or we reflect over the Y-axis. Okay. Now, V is going to be a vertical translation. So in this particular order, 1, 2, 3, and 4, we're going to do these different translations. And we'll talk about what they look like and how we go about them. So let's go ahead and jump down to our first function with our table. So now what we've got is this first graph, f of x. We're going to translate that into 2f of x plus 5 by applying the transformation to individual points. So up here, what we need to pay attention to is this location of the 2, which is in front of the f, and this x minus 5, which is inside the parentheses. So what I see here is that it's going to show up in the function right there, that x minus c, and we always do the opposite of that. So in this case, where it says minus 5, that's going to be a right shift. Because it's minus, we would think it would go to the left, but it goes to the right 5 units. So that's the first thing that we're going to do. And now this 2 outside, where does that show up? Well, that shows up right there. So that's where it shows up outside. This A is the value that's multiplied by that. And what we're going to do is we're going to multiply the Y value that much. So we're going to multiply Y. We're going to do 2 times whatever the original Y value was. So I'll show you what that looks like. Let's come down here and we'll look at our first graph and we'll think about how this is going to affect the function. So what we want to do is we want to think about these initial points in our graph that are influential. So this would be 1 right here. That's going to be 1. Up here, that's another influential point. This one right there and that one right there. So those are going to be the 4 points on this graph that are going to help us kind of define where the graph moves and is anchored. So this first point here is -6, -2. So we got -6, comma -2. And then up here, I have -3 and up 3. And then over here, I'm at -1, comma 0. And our final point is going to be over 2 and up 2, 2, comma 2. Now, what I did here was I sequenced it. This is a horizontal shift. So that's why it's number 1. Horizontal is number 1. So we're going to do a horizontal shift, which shows up right 5. Now the right applies only to the x value, right? Because the x value tells us right or left. So all of my x values, I'm going to add 5 to them. So -6 plus 5 is going to be -1. Now my y value is going to stay the same. I haven't done anything to that yet. -3 plus 5 is going to be 2, comma -2. -1 plus 5 is going to be 4, comma -2. And 2 plus 5 is going to be 7, comma 2. Oops, sorry, that's 0. Okay. Now for my second step of the translation, because there's multiple translations or transformations here. We have the shift here and the y dilation here. I take the y value and I multiply it by 2. So all of these y values are going to be multiplied. Sorry, all of these y values are going to be multiplied by 2, and the x value stays the same. So just so I don't screw up the x values, I'm going to write them down first. Okay. And then this -2 gets multiplied by 2 and becomes a -4. -2, sorry, that I screwed up also. That should be a 3. So 3 times 6 is 3 times 2 is 6. 0 times 2 stays 0. And then 2 times 2 is going to be 4. Okay. These are our final points. And when we plot that in a different color, we should see the transformation. So we go -1, down 4, over 2, up 6, over 4, up 0, and over 7, up to 4. Okay, so there was a right shift of 5 and a vertical stretch where we stretch all of the points away from the x-axis by a factor of 2. Now you'll see here that this one's up 2, and then here it's up 4. This one is up 0, and this one is up 0. So what's up with that? Well, the cool thing is that what we're doing is we're doubling the distance of the point away from the x-axis here. And since this point is already on the x-axis, we can't double 0. So that's why it stays here on that x-axis. Just like this point over here was down 2 units, this point over here is going to be down 4 units. So we doubled the distance away from that x-axis with each of these situations. That's what this y stretching did. All right, cool. Let's flip over. Okay. All right, now I'm going to do one more, and then I'm going to give you the chance to finish up on your own. Okay, so if we look at this next one, what we've got is the graph of f of x. So now what we're doing is we're sketching the graph of -f of 2x plus 3 by applying the transformation to individual points. So here we've got our original points on f of x. Now I use the same graph, so we can just copy those points from before. Now here, what we've got, again, is -6, comma -2. Up here, we have -3, comma 3. And then we have -1, comma 0, and 2, comma 2. Okay? Now what I did was I sequenced them correctly for us here, but on the next example, you're going to have to do that on your own. You're going to have to figure out what all of these are and what sequence they go in. Here we have a stretch, which is this 2 inside of the parentheses there. That's a horizontal stretch. Remember, anything that happens to the horizontal or the x value, x is going to be in the parentheses. And then we have a negative in front, which is a reflection. That negative flips it over the x-axis. And then this vertical translation here of +3. Okay, so that means we're going to add, we're going to go up 3 for each of our points. Here we flip over the x-axis. And here we have, this one is interesting. So let's go back to our table and take a look at what this 2 is going to tell us to do. So now we're here at this horizontal stretch or compression where we have a number that's inside the parentheses multiplied by that x. Now check it out. This thing here is x over k. Another way to think about that is that what happens with this k is it turns into a 1 over k. We take that number and we flip it over into the bottom of the fraction and we multiply it by the x. whatever that x value is going to be. That's a k. It looks kind of like an x. So we do 1 over k times x. And I'll show you what that looks like on this example. Okay. So this one here is going to be, since it's 2, we take it and we do 1 over 2 times whatever our x value is. Okay. So how does that show up? Well, 1/2, right? 1/2 of -6, 1/2 times -6 is just a -3, and our y value stays the same. 1/2 of 3 is -1.5, comma 3. That y value stays the same. 1/2 of 0 is, or 1/2 of -1 is -1/2, and y value stays the same. And 1/2 of 2 is 1, comma 2. Okay. Now, how do we do this flip over the x-axis? Well, let's check it out. Here, what we have is reflection, and we reflect it over the x-axis. And what we do is we take the opposite, or the negative, of the y value. So we just change the sign of the y. So our y value is going to be x, comma, -y. So we change the value of this one here. Since we've changed these points, now we're going to work with these points here. So I'm going to have -3, comma, +2, -1.5, and then this 3 becomes a -3. -1/2 stays the same. And then this 0 doesn't change because it's not positive or negative. And then we have 1 and -2, right? The 1 stays the same and the 2 becomes negative. Now, if for our fourth change, we have a vertical shift of up 3. So what that means is that all of our y values are going to add by 3. So we have -3, comma 5, -1.5, comma 0, because -3 plus 3 is 0. And then we have -1/2, comma 3, and then we have 1, comma 1. -2 plus 3 is +1. These are our final points that are going to give that shift to it. So let's go ahead and graph that and take a look. All right, so -3, up 5, -1.5, 0, -1/2, up 3, and 1, comma 1. So we flipped it over the x-axis, and we squished it by we squished it by a factor of 1/2. Here we did that 1/2, and we shifted it up 3 units. So that's what happened with our green function from our blue function. All right, I'm going to stop there, and I would like you to do in your groups numbers 3, 4, 5, and then oh, I wanted to do one more. Sorry, I've got to do one of number 6, so you can do the rest of those. So you can see what that looks like. Okay. All right. Now, when I look at my function here, I'm just going to look at this function right here, and I'm going to think about H, S, R, V. What do I have? And you can definitely go back to that table on the first page and think about what's what. So I've got a -2 and x plus 3 squared plus 5. So this is my parent function. I'm not worried about that. That's just kind of off to the side. This is the original function, the translated, transformed function that I'm trying to play with. So right here, this is going to be my vertical shift, always at the end outside the parentheses. So that's a vertical shift of up 5. Do I have any reflections? Well, I've got a negative here, so that's going to give me a reflection over the x-axis. Okay. If the negative was inside the parentheses over the next to the x, then it would be reflection over the y-axis. This stretch right here, that's a vertical stretch of 2, multiplies it by 2. And then do I have any horizontal shifts? Well, that's inside the parentheses. That's a +3. So I'm going to take the opposite of that, and I have a horizontal shift to the left of 3, right? Instead of going positive to the right, I do the opposite of what's in the parentheses and go to the left. Okay? All right, so now just do B and C on your own, see whatever you can figure out there. If you have any troubles, consult the answer key and then submit this homework on Schoology, please. Thank you. And again, I appreciate you being respectful and doing your work. I'll see you when I get back.